prove a trig identity. These are kind of fun. It's kind of like a puzzle. First, I'm just going to write down some basic identities, which you probably should know. Some courses, these are given, like in the IB, in the formula book. But anyway, you'll use them so often that you'll know them. All right. So we'll use some of these to help us simplify our thing, and that's that. Okay, so we're trying to show this. All right. Now, first, let's see, what are we going to be using? Okay, we're going to use the secant, which is the reciprocal of the cosine, the cosecant, which is the reciprocal of the sine, and then these last two, which are forms of the Pythagorean identity. All right. And then we need to pick a side to work on. So usually you pick the most complicated side and simplify it to match the other side. So in this case, I'm going to work on the left side. And then another good rule of thumb here is to change everything in terms of sines and cosines. Sines and cosines are a bit easier to work with. So all of these can be changed to be in terms of sines and cosines. So that's going to be our first step. So the secant is the reciprocal of the cosine, cosecant reciprocal of the sine, tangent is sine over cosine, and cotangent is cosine over sine. Multiply out the brackets like so. And then we have two fractions. In the left piece, we can take out a sine. In the right piece, we can take out a cosine. And then we can rewrite that as secant squared plus cosecant squared, like so. And then we use those last two in our formula book. The secant squared can be written as 1 plus tangent squared, and the cosecant can be written as 1 plus cotangent squared. 1 plus 1 is 2, and everything works out nicely. So left-hand side equals right-hand side, and we're done. Okay, I hope that was helpful. Let me know. That's it.